This conference will now be recorded.
Okay, so let's move on. So what we have seen yesterday is that we install a Minikube, and on top of that Minikube, we were able to run our containers, we were able to run our pod, we were able to run our replica set and deployment. So I know what is a pod, I know when a pod crashes, the IP changes, and then I have to go to something called services. Then when I talk about service, it does load balancing and gives me a static IP kind of thing, which I'll be using for my load balancing and other kind of work. So when I say that I'm using services basically are of four types. Three are which used for normal load balancing, internal load balancing, external load balancing, that kind of thing. And one is basically used for a headless service. So headless I'll be talking about later, but we saw that this service which I know is cluster IP, which is the default one, which is the internal one. Then I have node port, which is the external one. And the only problem with node port is it is having only a range of ports open. But if I go with load balancer, a bit costly, but it will give you a good connectivity to the outside world. Okay, so this is what my service is going to do for me. If a pod dies, it will link a new pod and associate that service so that the connectivity does not go for a toss. Now, there can be a scenario. Okay, let me come here. Okay, so there can be a scenario which we'll be discussing today. Now, let me say that there are few details. Now, let me say this is a front-end application and this is a DB application. So when I have to link my front-end and database together, there can be a lot of details which has to go from my database to my application, and from my application go back to database. So there are a lot of communications which are going to happen, like DB URL or endpoint and all those things. If the database crashes, again I have to rebuild it, push it to the repo, and again run the pod. The IP part will be taken care by my service, but what about the setup which I have to do again? So what we do is any configuration related data which we have, we put it in our config file, which we config map file, which we say are non-critical or non-confidential data. Any such kind of data, we can put it in config map and we can run that detail along with my application. So irrespective who is going, who is coming out, the data only has to be changed here, and accordingly the mapping will happen. But when I talk about database, there will be other details also, like DB username, DB password. So how do I manage these things? These are credentials which are critical. So obviously I cannot just go and hard code it in my config files. So I use something called security or a secret file, where I'm going to keep all these things and I'm going to encode it so that even if somebody sees my config files, he's not able to go ahead and see what the username and password is. So today we'll be learning about two components. One is your username and password, which will be lying in my secret file. And then I'll be learning about something called config map, where I will use the non-critical data. So this is how this is. So what we will do today is we'll not be using a normal Minikube which we were using last time. We will be rather going ahead and creating our own cluster on cloud environment. So to make that setup work, what I have done is I have already the set of commands which are needed. I have put it in my GitHub. So I'll be using those set of commands to get my work done. So let me come here. Okay, and if I come here to this guy, Kubernetes Setup. So these are the set of commands which I'm going to use. But before running this command, I would like to explain what I'm trying to do here. So if I come here, so I'm going to build, or I'm going to make a cluster with nominal configuration. Means I'll have one master node and two worker nodes. But to communicate this with this machine, I need a place where my client will be installed or my kubectl will be installed. So what I will do is I will take one machine, two machine, three machine, four machine. So I'll make four machines, and using those four machines, I will do my work. Okay. So this will be a Ubuntu machine where I will install kubectl and all the things required. And from this machine, I will start talking to my master, which will in turn talk to my worker nodes. And inside worker nodes, my containers will be running and master will be managing that. So I will try to do this. Then later down the line, what I will try is I will go and put my config files so that I'll put it here so that this config file go and run in my worker node. So this is the entire setup which I'm planning to do. So first, let's concentrate on this guy and then we'll come to these guys. So the configuration is little bit mechanical, nothing very fantastic or anything will do like that. But then we have to follow step by step whatever is needed. So I am going to do with on a cloud environment. So I will go ahead with some cloud basic knowledge and then I will start the work. So the first thing what I'm going to do here is I will create a role. Now what is a role in AWS? So if you say role, I will talk about IAM. So IAM is a component which access the AWS resources, like which resource will get what kind of access. That kind of details are stored here. So if I come here to IAM, I need IAM basically. Okay. So I'll come here to this guy called role and I can create a role. So role is nothing but it is like giving power to my EC2 or my server to do whatever it wants. So I will give the powers. What power I'll give? So create a role. And who is going to use it? So my EC2 is going to use it. Basically, my Ubuntu machine is going to use it. I will give admin power. So I'll say admin. Okay. I will give EC2 full access, means anything you can do with my instances, because at the end it has to launch more instances. I will give Route 53 access. Now Route 53 is a DNS service which we will be using. Then we will give him S3 full access. Now S3 is nothing but it is my storage, and IAM full access. So basically these 5 access is what I'm going to give. Okay, go ahead and just give a name. So I'll say Kubernetes admin. Okay, and this is the guy 1 2 3 4 5. So these 5 access is what I have given. Just go ahead and say I want to create a role. So this role is created. Is it a standard to give? No, it's not a standard to give these access. Basically, I'm giving full access. So in prod kind of environment, definitely you're not going to give all the full administrator privilege. That is not what is expected. You precisely go and tell what is actually you're looking at. Okay. Now this part is done. Then the second part here is I would like to have a storage where I can go and keep all the data which is going to get generated. Okay. So obviously the storage which you are looking at, so we need to know exactly each, yes, you need to know exactly what it is needed. Correct. So what I will do is I'll create a bucket. I'll create a storage. Okay. So I will go here and say create bucket, and you will be giving a unique name to your bucket. It can be anything. So I'm giving a name like uh, evening or learning. So I'm giving demo.k8s.learning.net. So this is a name I have given. You can just give any name of your choice, but follow this pattern. It is good that if you follow this pattern. I'll tell you why I am following this pattern. Okay. Then just come down, leave everything as it is, and create a bucket. So basically what will happen, this bucket will get created and you will be using this bucket to store all the data. The third thing which I'm going to do here is Route 53, which is a domain name service here, scalable DNS thing here. I'll come here. I don't have a stuff, or I don't have that particular, what you say, that domain name. So I'm going to take a domain name from here. This should have been deleted. Just let me delete this. So here you can come and you can say, I want to create a hosted zone. Click on this. You can give a name of your choice. So I will give the name as learning.net. Learning.net. Okay. And you can give the same value here. Okay. And it's not a public one. It is private to my AWS. So I'll say private. And where are you putting it? So I'm putting it in Mumbai region because I'm doing all the work in Mumbai. So choose a region. This is Mumbai, AP South 1. Here I'll have a default VPC, put it inside the default VPC. Come here, create hosted zone. So basically I created a role, I created a Route 53, I created a storage, and now it is time to create the EC2 or the server from where I will start my work. So this is the EC2, click on this. So I don't have anything running. I want a new machine, a Ubuntu machine where I can do my work. So I come here and say Ubuntu, Ubuntu, enter. So I'll take this 18.04, click on this, and then whatever normally I do, T2 micro, instance detail. Now here I will do one small change. If you come here, why not? You can use AWS Linux also. There's no problem. Any version of AWS, any version of Linux is compatible. There's no problem here. So I can use this IAM rule, the one which I've just now created, Kubernetes admin. Come here, add storage. Same thing, whatever I have been doing till date. We were used to it. No worries, you can just adapt. No worries. You can try with that also. It will work. I will say K8s admin or management. So I'm saying K8s management server security group. So you can use a security group which you already have. So I'm using this Mumbai security group. Just go ahead and launch it. So I'll wait for this EC2 to get launched. And one thing which you will see here is that the default user for this guy is not EC2 minus user, but the default user will be Ubuntu. So copy this, come here and say putty, and here you will say ubuntu at the rate whatever IP address you got. Appearance change 16, okay, SSH auth browse, and this is the key I've used. Just open it up, accept. Now how do I know the default user was Ubuntu? If you come here and see connect, you will see that default user is Ubuntu here. Back to your instance. So if I come here, it says if you want, you can you can go become a root user. So I'll say okay, sudo minus this thing. If you want, you can give a name like post name. I will say K8s admin sudo su hyphen. So I'm an admin here. Let me clear out this thing. Now here you don't say yum update. Here you say apt update. Apt update -1. So instead of yum update, you say apt update. It will update everything, whatever is to be updated here. Now I'll come back to my document now. So it says set up a Kubernetes cluster on AWS, done. It's an Ubuntu machine, and apt get update is what you should run. And then you should go ahead and install few softwares like AWS CLI is what will be needed. So take this command. So I'm basically installing AWS CLI. It's a big package, looks like. Let's wait for the installation to get over. So it is saying AWS CLI installation is done. Now if you come here and say AWS minus version, you can see AWS CLI 1.18. Is CLI needed to manage AWS? Yes, CLI will be needed to manage AWS thing which I'm going to create. So I need AWS CLI, I need Python, and this is the Linux machine which I have. Okay, done. So this till this point it is done. Python I've checked. Now I will need few softwares like to interact with Kubernetes cluster. I would like to have this thing kubectl. So there are a set of commands. I'll just take them and run it. And towards the end, if I install this successfully, if I say kubectl version, I can see 1.22.4 is what is installed here. Okay, this I have installed kubectl basically. Then there is something called Kops or Kubernetes operations is what you have to install. Just take this chunk, put it here. So these are some standard packages which you have to install: AWS CLI, kubectl, and Kops. So you can come here and say Kops version. So it says this is the version of Kops or Kubernetes operations. Then I have created an IAM role, I have created a S3 bucket, I have created a Route 53. So I have to, can you please revise kubectl and Kops? So see, kubectl is, if you remember the diagram which I was showing you some time back, I told that this is my cluster, master, worker, worker. But these two worker nodes, I cannot, or these master node, I cannot directly go and talk. I need a agent. So this agent is kubectl, and to install this agent, I need a machine. Okay, so this machine is my Ubuntu machine, and on top of that, I have installed kubectl because I want to talk, and I have to install Kubernetes here. So for that, I need Kops and AWS CLI. So this is what I have installed here: Kops, CLI, and kubectl. So these three things is what I have installed. All these are standard packages. You have to just go ahead and install it, nothing extra here. Then you have to tell that whatever variables are going to be generated, you have to put it here. So if you remember, mine was learning.net. So I'll say export Kops state, whatever state is getting generated or temporary data is getting generated, put it here in learning.net. This is exactly the same bucket which I have created, or the S3 bucket which I have created. Then to do a SSH connectivity, I will need this keygen. So I will do a SSH keygen. SSH keygen. So it says, would you like to go ahead? I say yes, yes, yes. So basically a private key and a public key has been generated. This is the private key, this is the public key which has been generated. Now, once all these things are done, you can go ahead and create your cluster. So to create the cluster, this is the command. So let me just go back and start from the very beginning. See, Kops, create cluster. Where are you creating? So I'm creating on AWS. What is the zone? So zone is nothing but which place you're creating it. So if I come here, I can see it is AP South 1, and my machine is running here in AP South 1A. So I'll run it here only. So I can come here, AP SOU AP South 1A. Okay, so I'm running it here, AP South 1A. Then the name is demo, and this name is going to be exactly similar to my bucket name. Okay, so I will say demo K8s dot learning K8s learning.net, similar to my bucket name. Okay, demo.k8s learning.net, and the last one is DNS name, which I have given as learning.net, and this is a private one. Just go ahead with all these details, enter. So it's saying the Kops version and all. So now you need to copy these things. This 3-4 things is what we need to copy. Paste it here. So it says if you want to see what is going to get created, you can run this command called kops get cluster. So it says there is a demo K8s learning.net which will be created on AWS cloud environment in AP South 1A. Second command talks about the cluster. So whatever cluster will be created with this configuration file. So if you want, you can go here and say nano, or you can just go here and see what is there. So again, API version, this is the API version, this is the kind, this is the metadata, this is the spec. So all these details will be mentioned here. I did not make any changes, I just came out, but this is what I want to change. So if you go with this guy, it says your nodes or your worker nodes will be configured with this command. If you go here, it is talking about instance group and it is giving you T2 micro. So if you go with T2 micro, it is costly. So say escape I and make this T2 micro as T2 medium as T2 micro. Why? Because at the end of the day, I want that cost should not be the factor. Max size is 2, min size is 2, means I am getting two instances here. If you want to increase the size, definitely you can make it 5, 10, whatever you want to. But I will stick to 2. Similarly, in my master, I can edit the master details using this command. Again, if I come here, I can see here that it is C4 large, again a costly thing. I'll again make it T2.micro. So T2.micro, and I will say, okay, so I made all the changes. Now it says, once you have done all the changes, finally, if you want to configure your instance, you run this command basically. So if you go and run this command, kops update cluster, so you can see, gradually you will see that everything is getting created, a private, okay, related. So I ran this command, kops update cluster, and see here, kops update cluster, this is the command which I ran. So, okay, let it come here. So it's saying a new version of kops is available, you can use it. I'm saying I'm not interested. Then DNS validation, because it's an internal one, it is not validating. etcd is getting created here, see here, API server is getting created here, and this is getting in the master. So kops got installed, kube controller got installed, kube config got installed, kubelet got installed, kube proxy got installed in my worker node, and using the IAM role which I had given, it was able to create all the stuffs here. And then it says kops has set your kubectl context to this guy, means you can start your work here, but the cluster is still starting. You should wait for a few minutes to get your work done. But if you just want to see what has happened, you can run this command, or you can just come here and say kubectl get nodes. So as of now, the nodes are not ready, so it will not run. But once the nodes are ready, you can come here and see. Let me just do Control C. I will come here and run this command, kops validate cluster. Okay. So if you see here, if I run this command called kops validate cluster, it says I am going to create the cluster using kubectl which you have installed. This is the name I'm going to give, and inside that cluster, I will have nodes or worker nodes whose count is 2 and a master node whose count is 1. And as of now, the DNS API validation has failed. It is telling, please wait some 5 to 10 minutes before the master to start. But before doing all these things, you should copy this set of commands and keep it with you. Okay, so this is what I have to wait for, kops validate cluster. Once it is ready, I can SSH into my machine using this set of command. Okay, or I can SSH, or I can connect to my master node using this command. Okay, so I will wait for another 2 to 3 minutes, max 5 minutes, to make this thing work. Okay, but as of now it will give me that only validation failed. Okay, so another 2 to 3 minutes, I'll go on mute, and once this is up, I will join. Give me 2 minutes. Meanwhile, if you have any questions, you can put it ahead. I do agree, each step has a lot of things, but you don't have to do every now and then. Like in a prod environment, if there is a admin, he will just do all these things and he'll give it to you. So it is not like every now and then you have to do this. It is like once in a while you will be doing this. Okay, so need not worry about it. More importantly, if you want, the same content is available here on internet. Cube or Kops to install K8s on AWS. So basically you can read through this document, exactly the same thing which I'm doing, they are also doing. So they will tell you if there's a Linux system, what you have to do. So basically here they are installing Kops, they will install, see, they're installing Kops. Then they will install this Route 53, which I did. Then they are creating a domain name here. Then they're using this S3 bucket, which I did. Then they're building the cluster here. And then using this command, kops update cluster -- yes, which is exactly what I've done. They are building the stuff here. I'll further wait. Yes, Azure, it will change because Azure will have commands little bit different, not 100% different, little bit different. So if you are like, you don't want to do this at all, you can go on AWS and you can look for something called EKS, or Elastic Kubernetes Service. So it's a ready-made solution. You don't have to do anything. You have to just go ahead and start using. Similarly, on Azure, you have something called AKS, Azure Kubernetes Engine. On GCP, you have Google Kubernetes Engine. So these are ready-made solutions, fully managed Kubernetes control plane. But then you don't get a chance to learn all these things. Obviously, using these are much more simpler than using the one which I'm showing right now. But initially, only if you go for the easy ones, then you will not be able to learn the stuffs. Kops validate cluster. Yep, it has failed. But I can see here. So if I do a Kops validate cluster, I can see that the cluster is getting validated. This is the master node. This is the worker node. And this is the IP which I get for my nodes. See here, this is 1, 1, 1. So I can see this is my master node and there are two worker nodes which have come up. Probably this time if I come up, it is ready. So I can see here it is saying cluster is ready. And this is node 1, node 2. This is your master node. Okay, so if I come here and say kubectl get nodes, so I can see three nodes are there. One is master and it was created first, and then two worker nodes are created. Okay, so still I am in Kubernetes admin, the Ubuntu machine which I created. I want to go inside the master and do the work. So I will run this command which I've copied here, ssh-i. So it says, do you want to continue? I'll say yes. And if you see here, I'm logged into 172.20.61.222. If you see carefully, 172.20.61.222 is nothing but my master machine. So I'm admin here. I will change myself to root. So sudo su hyphen, and I can change the name. So I will say host name K8s master, and sudo su hyphen. So you can see this guy. Let's clear everything. So this is my master node. Here, if I come here and say kubectl get nodes, I can see one master and two worker nodes running. And this is the exactly same point from where you start in a Minikube. You just have everything pre-installed and you just start your work. But now what I have done, I have spent a half an hour or more than that to get this server up and running. Now, the same commands which you were running there in your machine, in a Minikube machine, you can run it here. So let me say I want to run some Nginx container. Okay, so I can run it here. kubectl run sample nginx replica 2. So if I run like this, it says deployment nginx created. And now if I come here and say kubectl get all, I can see two pods are running because I gave replica as 2, 1, 2, and this service is a cluster IP, which is the default one, and this is the deployment, and this is the replica set. If you come here again, you can see one by one running. Cluster replica set is 2 and deployment is 2. Now if you want to make it work externally, so you can also run something like this. kubectl expose the deployment and the type is load balancer. So now if you come back here, you will see a new sample nginx has been created with type as load balancer, and this is the IP address where it is running. Okay, so internally, if you go to AWS and you go back to your EC2 and you come down here to your load balancer, you'll see here one load balancer is getting ready. I can show you the time. See here. One second. So November 25th, 2021, 90545. So it is like some 15 seconds back it has been created. So I just want to go and see the health check. Wait a second. I will show the instances which are running here. Just maximize this. So it is, these are the instances which are running here. Description. So this is what I'm looking at. Yeah, this guy, DNS name. So if you take this, this is where your machine should be running. Let me take this. Welcome to Nginx. Where is it running? It's basically running here inside my master, and I'm able to see outside with the help of this load balancer, and I can very well see here it says service sample nginx and load balancer, and this is the ID which I'm using, which I got from there and I take from here. Both are same. I can show you that. See here, it is same. Now I can show you one more thing. If I come here and say kubectl delete sample nginx, I just go ahead and delete the sample nginx which I've created. One second. Delete deployment. Okay, So this has been deleted. Now if I come here, kubectl get all, you can see the things have been deleted. And now if you come here, it will not be pointing to anyone because I don't have anything running. So if I come back here and do a refresh, it should fail. It's looking for the container or the pod where it has to run, but definitely the pod is not running. I've terminated the pod, so it will also not point to anything. So it will wait for a long time and then it will give me a error page. Let's wait for that. So definitely it will, see here, it has not responded. Why it has not responded? Because the entire cluster has been deleted. I can come here and delete this also, kubectl delete service and this particular service, which is sample nginx, delete. Now there is a concept here which is called daemon set. Okay, now daemon set. Now it's very easy to understand a daemon set. So let me say that you have a cluster. Okay, let me say this is my cluster. Okay, now this is my cluster, and you want that inside this cluster on each machine, okay, on each machine one monitoring tool should work. Now let me say each machine's availability can be different, like one machine is 10% available, the other machine is 20% available, and the other machine is 80% available. Let me say this is 80% available, this is 10% available, and this is 50% available. So if some requests come here, probably it will go here because this is free, 80% is free. But the request which is going to come is saying I want one monitoring here, one monitoring here, and one monitoring here. So if you want this kind of a setup where you say that I want that on each machine, whatever number of machines are there, and whatever number of machines which are going to come in future, for each I want a new deployment to happen, or whatever I want to put, it should at least go 1 1 1 1 1. Not everything should go in one node. Every node should have at least one monitoring application. So that kind of setup, if you want to do, we say it's a daemon set. Okay, so if I have to deal with daemon set, the scenario or the work is very easy. I will just go ahead and create a daemon set file. How does it look like? So this is again a simple thing. So here, what you basically do is you use this. So here you say this is an API version whose name is daemon set, and then you give a name to this, and in the spec section, okay, precisely here you say what image you want to run, what image you want to run. It is very similar to, if you come here, wait a second, let me take this guy. I will sum here and say nano, and I'll paste this guy, and let me just come here. If you see carefully, this guy is very similar to a normal deployment. API version is there, apps v1, kind is daemon set instead of deployment. Metadata, you have given a name to this guy. In spec section, there is a match label which is going to match this name. And inside spec section, there are containers, Fluentd container, which is going to be pulled from GCR or Google Cloud Registry. Google, rather than pulling it from github.com, or sorry, from dockerhub.com, it is being pulled from Google Container Registry, and there is a match label of Fluentd. Okay, so I've never mentioned a replica, but there are two nodes running. Okay, and it will go and map itself. So it says two nodes are running, means I need two instances of that. Okay, so it's a very simple thing. So I'll just come here and say, first I will say kubectl get nodes. I can see these nodes are there. I can also do one thing, minus O wide, sorry. So if I take it outside, so this is what I want to show you. So this machine has a internal IP address, different IP address, different IP address. So I have basically two worker nodes. So top two is where I'm aiming at, okay? This guy and this guy. Now, when I deploy my daemon set, okay, they will accordingly go and one will go and sit here, the other will go and sit here. So if I come here and say ls minus l, I can see this fluentd is there. Fluentd is the image, or it's a tool which will monitor the applications. So I'll come here and say kubectl apply minus f and this guy. So it says daemon set created. Now if I come here and say kubectl get ds or daemon set, it will show me that the desired state was 2. How did it know? Because two nodes are running, and as of now available is 0, means it is still coming up. So in some time you'll see they are ready and available. But if I come here and say kubectl ds minus o wide, wait a second, kubectl get nodes. One second, let me show you how it's running. If I come here and say kubectl get pods minus o wide. So what I actually want to show you here is, copy this line, paste it here. So there is one instance of fluentd, another instance of fluentd, but the interesting thing here is that one is running here 172.43.213, which is this guy, which is one of my worker node, and this is this guy, which is my another worker node. So it quickly realized that there are two worker nodes running, and the daemon set is asking me to run one instance at each. So it went ahead and itself created two copies of itself. One was running on this node and the other is running on this node. So when you say a daemon set, it is for even distribution of work among those worker nodes. Okay, this is daemon set for you. Now, I will again come here and try to design this application where I will have a secret file, I'll have a config file, I'll have this application. Okay, and I will try to link this with a service. So the first thing first, I'll again come back to my documentation, which is here, and I'll go here. Now, first what I will do, I'll create a config file. So it's all about how you write a config file. So I'll create mongo config.yaml and I'll paste this guy. If you read this API version, which is v1, kind is going to be a config map. Metadata is the name what you are given. And the important thing is that inside this config map, you have something called Mongo URL, which contains the URL to your database. Control X, Y, enter. I'll come here and say kubectl apply minus F and this mongo config.yaml. So mongo config created. I can come here and say kubectl get. I have created a config map. So I'll say config map. I can see one config map has been created some 16 seconds back. It has one data, and that one data is nothing but my Mongo URL. Similarly, I'll create a secret file, but before creating a secret file, let me do this work. what I'm trying to do. So my username is Mongo user. I don't want to hard code it. So I'm doing a base 64 encryption of that. So this is my encrypted value for my username, and this is the encrypted value for my password. So my username is going to be Mongo user and my password is going to be Mongo password. And let me create a secret file. Just take this guy completely. So I have an API version, which is again v1. The kind is going to be a secret here. Metadata, I give a name. Type is one of the secret type I given. And there are two variables here. One is Mongo user and Mongo password. But I'm not hard coding the actual values. I have done a base 64 encoding for both of them and I am just pasting it here. So I can come here and say kubectl apply Mongo. This is Mongo secret. You can see Mongo secret created. Come here and say get kubectl get secret. You can see here this Mongo secret with the type as opaque has been created and two items are there. 13 seconds back it has been created. So this I have done what I have created via my MongoDB and Mongo secret and Mongo config map file. Now what I'll do is I'll go and create a deployment file. In fact, two deployment file is what I'm going to create and just mention what all I'll do. One is the database component. So if I come here, one is for this guy and a service file associated to this. And the other one is this guy, service file associated to this. So just let me copy it first and then let me explain you. Let me come here and say, see here. So I'm deploying a file called mongo.yaml. Here I'm saying this is a deployment file, API version v1, and I have given a name as Mongo deployment. I'm saying I need only one replica of this, and the label is going to be Mongo. So if the service has to find it, it has to find with this keyword Mongo. Inside that, I'm going to run a container with name as MongoDB, and it is going to pull my hub.docker.image of Mongo 5.0. Internally, it will run at port number 27017. This MongoDB will need root username and root password. This root username will come from the secret file. Inside the secret file, there is something called Mongo secret, and inside that Mongo secret, there is something called Mongo user. So it will take the value from Mongo user. Similarly, here the value will come with password. Then I'm going to create a service file with the name as Mongo service, and I'm going to say that the selector is going to be this guy, app Mongo, and it is going to run here at port number 27017. Okay, so this is what I'm trying to tell here. I'll come here and say kubectl apply -f and this mongo.yaml. So two things, a deployment and a service will be created for me. Similarly, I will also come here and create a deployment file for my web.yaml. Let's copy this. In this application, secret needs to be yes. So one second. In this application, these secrets need to be retrieved by the code, I guess. Yes, this will be retrieved by the code. I'll just show you how it is getting retrieved. Now, if you come here, this is your deployment file, apps v1, the name web app, and it's going to run this with this tag name. And here I have created a image which it will be using. And if the username which you're talking about, this is the username environment variable, which is going to come from the secret file. There is a Mongo secret file inside which the Mongo user is there. Similarly, the password will come from the secret file, which is Mongo password, and the configuration related details will come from config map. And there is something called Mongo URL. And then you can come here and you can run this. Okay, so you can make a small change here. You can come and make this as type as node port. You can keep it as load. You can make it as load balancer. Okay, Control X, Y, enter. Finally, kubectl apply -f this web app.yaml. So now if I come here and say kubectl get all, I can see there's a load balancer getting created and it's going to run here. Okay, so I have to open these port numbers basically to see whether these load balancers are running or not. But meanwhile, you can see here it is still coming up. It is not ready. So wait for some time. See here. For Mongo, you told one is needed, one is available. For deployment, one is needed, one is available. Okay, deployment is running, replica set is running. So everything is running for me. So I can go and try this guy. And it will run at 301,000. So let's try this. 30, what's the port number? 301,000. 301. Once again, something went wrong. See here, it is running here. This is the port 3000 where it is running. So I gave my load balancer followed by my port number, and this is what I can see here. So if you want, you can make changes here. Edit profile. Kumar. Then you can come back again. So what you can see is that this data is actually getting stored. So this data is getting stored in my MongoDB. And the internal connections, whatever I'm doing is I'm doing with the help of my config file and with the help of my secret file. Okay, so this thing will need a good amount of practice. The daemon set, the secrets, the config maps will need a good amount of secret, the service which I have taught you. So what I'm expecting from you is that take your time. Tomorrow there will be no class. Saturday, Sunday there will be no class. Take your time. Go ahead. Try to understand all these concepts. Okay. The recordings will be shared with you. Go through the recordings one by one. You will see everything. Slowly practice at your own pace. The code whichever I'm using is available here. You can fork this repository and use it. Okay, so for this repository, start using this code, and once the code is running, you'll get confidence, and also you will learn what is happening around. Okay, so that is all for today. Oh, I know it was a heavy class, but then gradually is what you will learn all these things. And please do practice. If you do practice, things will become seriously easy and you will be able to understand everything. On that note, I will close it for now. In case you have any questions, you can put it ahead. Yeah, no worries. Okay, see you then, guys. Bye.